All right, we're continuing our hodgepodge of polynomial graphs. So our next concept is identify relative extrema graphically. So relative extrema of a graph refers to either the relative maximums or relative minimums. Now, a relative maximum, that is going to be a high point or a hill or a mountain of the graph. However you want to think of it, it is just going to be a high point. A relative maximum, a relative minimum, my apologies, that is going to be a low point or a dip or valleys on the graph. So as you can see, we have two functions graphed below. So this first one, how many points on the graph represent relative maximums? And then we want to identify them. So again, maximums are high points. So if I look at this graph, I have a high point here, and I have a high point here. So we're identifying all the high points, not necessarily the one that is the highest. So as you can see here from our graph, so we have two relative maximums, and the variables that they're at, these are at B and E. Now in Delta Math, you're just going to identify how many. You're not going to have to write out which variables they are. In our notes, I just wanted us to do that just to reinforce the topic. So now for our second one, how many points on the graph represent relative minimums? So these are our low points, our dips, our valleys. And again, we're not looking for the lowest, we just want all low points. So here's a low point, here's another one, and here's our final one. So here we have three relative minimums, and these three minimums are at A, D, and F. So that is all there is for relative extremas. All right, our next concept, odd and even polynomial functions. So you will not see a graph in this skill. Instead, it's going to be an equation. So we need to determine whether a polynomial is odd, even, or neither. And all you need to do for this is to look at the exponents. So all you need to look at are the exponents. So if it is an odd, that means all exponents are odd. So they all have to have an odd exponent. If it is even, all exponents are even or a zero, meaning it's just a number, no variable attached. You can also have neither even or odd. And what that means is it's going to have a mix of even and odd exponents. So we need to determine whether the functions are even, odd, or neither. So our first one, we have x squared minus 9. So as you can see from our exponent, we have a 2. And then 9 has no variable, so it's a constant, so it's 0. So both of those things line up with this being an even function. Our next one, we have 6x, and when we just have x, remember the exponent is 1. So we have a 1, a 5, and a 2. Well, 1 and 5 are odd, but the 2 is even, so we have a mix of even and odd. So this means this is neither even or odd. And then finally, the third one, we have for our exponents a 3, a 7, and again, this last one here is a 1. So 3, 7, and 1, those are all odd exponents, so this function is odd. So that is how to determine even or odd from a polynomial function. Now, continuing with even and odd, now you're going to have to determine even or odd from a graph. And as you can see, I've reached the end of my paper, so the examples for this are going to be in the next video on the next page of notes. So we will now look at a graph to determine two things. The degree is even or odd, and when the function is even or odd. So there's two items here. So we have even, we have odd. So for a degree to be even, that means both ends are going the same direction. So that means on our graph, the ends of the graph are going in the same direction. They're either going up, up, or down, down. Now, for it to be an odd degree, this means that the ends are going the opposite direction. So that means one can be going up, the other is down, or down and up. So even, ends going in the same direction. Odd, ends going in opposite direction. So now let's talk about how to tell if the function is even or odd. So we're identifying two things here. If the degree is even or odd, or if the function is even or odd. So for the function, for it to be even, it's symmetrical about the y-axis. So that just means if we were to fold it in on itself, it's folding in around the y-axis. And then for a function to be considered odd, it is symmetrical about the origin. So it rotates symmetrically around 0, 0. Now, it's going to be a lot easier once we actually see the graphs. So, sorry about that wobbliness, but sit tight. We're now going to look at examples for even and odd from a graph.